Square DEFG is inscribed in triangle ABC. The areas of triangles ADG, BED, and CGF are 1, 3, and 1 respectively. What is the area of square DEFG? Feel free to pause the video and try this problem yourself. Once you're ready, hit the play button to see the solution. Now, for problems like this, it's helpful to start by identifying what we need to find and how we can use the information given to solve it. In this case, our goal is to find the area of square DEFG. To do that, we first need to determine its side length, because the area of a square is the square of its side length. So let's call the side length of square DEFG C. Our task is to find the value of C square, which will give us the area of the square. So let's use the information we've been given so far, starting with triangle BED. We know its height is equal to the side length of the square, which is C, and its base is the length of segment BE. So the area of triangle BED is 1/2 BE multiplied by C. Since we were given the area of triangle BED as 3, we can set up the following equation. So solving for BE, we get BE is equal to 6 divided by C. Likewise, for triangle CGF, the height is against C, and the base is the length of segment FC. The area of triangle CGF is 1/2 FC multiplied by C. And since we were given the area of triangle CGF as 1, we can set up the following equation. And solving for FC, we get that FC is equal to 2 divided by C. Now, triangle ADG is slightly different because we don't have a height equal to the side length of the square. However, the base of triangle ADG is the side of the square, which has length C. So we can draw an altitude from point A to the segment DG and call the length of the altitude B. We can then find the area of triangle ADG as 1/2 C multiplied by B. And since we were told that the area of triangle ADG is 1, we can set up the following equation. And solving for B, we get B is equal to 2 divided by C. So far, we've used the information given to us. So now let's look at other relationships that can help us solve the problem. One thing to notice is that segments DG and BC are parallel. And by viewing AB and AC as transversals, we can see that corresponding angles are congruent. This means that triangles ADG and ABC have two pairs of corresponding angles that are congruent and share a common angle at vertex A, making them similar triangles. Another way to see this, though perhaps not as convincing as the first method, is that scaling triangle ABC by a certain factor results in triangle ADG. So now that we've established the similarity of triangles ADG and ABC, we can use the proportionality property of similar triangles. To do this, we compare the sides we know in terms of C. By drawing an altitude for triangle ABC, we know that one side has a length of B, and since the other side is congruent to the side length of the square, it has a length of C. Therefore, the total altitude of triangle ABC is B plus C. Since the triangles are similar, the ratio of the altitudes B and B plus C must be equal to the ratio of the corresponding sides. We need to find two other sides in terms of C. We know that segment DG has a length of C, and BC is the sum of BE, EF, and FC, all of which we can express in terms of C. So the ratio of B to B plus C must be equal to the ratio of DG to BC. Now, rewriting BC as the sum of the segments BE, EF, and FC, we can substitute the values B equal to 2 divided by C, DG equal to C, BE equal to 6 divided by C, EF equals to C, and FC equals to 2 divided by C. And so, substituting this into the equation, we get an expression with both sides in terms of c. And simplifying this, we eventually get the equation c to the power of 4 equals to 16. Since our goal is to find c squared, which is the area of the square, by taking the square root of both sides of the equation, we find that c squared is equal to 4. And so the area of square DEFG must be equal to 4. If you found this video helpful, please give it a thumbs up and consider subscribing for more problem solving videos like this. Thanks for watching.